Hey everyone, I'm Shah. In this video, I'll discuss how you can improve your AI apps with automated evals. I'll start by describing what evals are and why they are important, and then walk through a concrete example where I used an eval-driven approach to systematically improve a LinkedIn ghostwriter. The thing that makes LLMs so powerful is their ability to perform arbitrary tasks from just natural language. We could give it a popular book and ask it to summarize it, and it would come up with a nice concise summary for us. Then in the very next moment, we can say, actually, I want you to write a new chapter to this book, and it will be able to do that as well. Or you can do something a bit more technical and sophisticated and ask the model to analyze all the literary devices used in chapter 3 and visualize them in a plot. And this typically works pretty well because if we're just having the LLM do ad hoc tasks through an interface like ChatGPT or Claude, you can always manually review whatever output it spits out and make sure it is error-free or good enough for your specific use case. But this approach does have its limitations, and that's simply because human evals don't scale. So for example, if instead of just doing one chapter, we wanted the LLM to analyze all the literary devices in all of the chapters and visualize them in plots, then this is going to take significantly more work from us in the manual review process. But okay, maybe I have to review a dozen plots. This isn't such a big deal. But what if this went up in order of magnitude and there were like over 100 plots that you had to review? So whatever your tolerance for tedious verification work might be, there is going to be some limit where human evaluation is no longer viable. In these cases, the natural thought is, well, we have these powerful LLMs and we have powerful computers. Can't we just automate these evaluations? So that's exactly the idea with automated evals, which is getting computers to evaluate LLM responses. So now we can do the same task of analyze all the literary devices and visualize them in a plot, but now instead of having a human manually review and verify this, we can just have an LLM judge verify the output. To the LLM, there's really no difference in evaluating one of these outputs or evaluating 100 or 1,000 of these outputs. This scalability is very important because automating these evaluations unlock the systematic improvement of LLM applications. For example, the typical way of improving an LLM application. So let's say we want to improve it through prompt engineering. The typical workflow will look like this. We'll generate a prompt, we'll give it to the LLM, we'll have it generate an output, and then we'll manually review and verify the output. And then based on our evaluation, we'll actually go back and refine the prompt to correct for some subtle mistakes, and then we'll give it back to the LLM, spit out another response, and then we'll do another evaluation. We'll see that there are some other issues that came up, and then we'll update the prompt again, give it to the LLM, generate an output, evaluate the output again, and just continue in this loop until we have a prompt that is pretty good. By automating the evaluation process, we go from this manual workflow to automating this whole process. What this unlocks is with the manual evals, maybe you'll look at tens or hundreds of examples, but if you're automating this evaluation process, there's really no cap on the number of times that you can go through this loop. And even if you do have some kind of budget constraints or time constraints, you're going to be able to go through this loop much faster if a computer is doing the evals versus a person. What this means is if you're only looking at 10 or 100 examples and refining your prompt, you're only going to see errors that tend to come up 1 to 10% of the time. So if you're building an application and then deploying it to thousands of users, there are going to be errors that come up in production that you just never would have seen in development because you're not looking at enough examples. However, if you've automated this process, you can see those errors that only come up 1 in 1,000 times or 1 in 10,000 times. These errors that only come up when you scale your system. Now that we know what automated evals are and why we should care about them, how do we actually create these things? Just to recap, an eval is simply a number that correlates with a good or bad LLM response. Now, I actually talked all about this in a previous video on evals, but here I'll just do a quick recap on the two ways we can automate evals. So the first is we can have code-based evals. This is things like computing the length of an LLM's response, counting the number of times a specific word or string occurs in a response, checking the formatting, seeing if the response is in Markdown, markdown or contains some XML tag or is proper SQL code, and on and on and on. There are endless code-based evals that we can implement, and the specific ones that you create are going to be specific to your use case. The other way we can automate evals is using LLMs, and in the previous video I talked about two key categories for LLM-based evals. There are global evals, so basically assessing if a response is right or wrong, good or bad, or we can have relative evaluations. Basically, the LLM just tells you if one response is better or worse than another. Each of these types of evals has its pros and cons. The pros of code-based evals is that they are relatively easy to implement and they're easy to interpret, because if your evaluation is simply checking if the LLM outputted Python code that actually runs, that's a very black and white, very easy to interpret evaluation. However, the downside of code-based evals is that they may not track with your desired result. For example, if you want to evaluate the empathy of a customer support chatbot, then that's going to be something that's pretty hard to implement using some kind of code-based eval. And so you'd probably need to turn to something like an LLM-based eval. The number one pro of using LLMs to do evals is that you can basically evaluate anything. You can evaluate things like empathy, how well the response captures a specific style, the quality of a summarization, and so on and so forth. However, the downsides of LLM-based evals include they are difficult to implement. As I'll talk about later in this video, building your LLM judge can be just as much work, if not even more work, than building your main AI system. And then the second thing is that LLM-based evals are never going to be perfect. They're going to have some empirical accuracy that you're going to have to take into account when you're using it to grade outputs from your main AI system. So to make this all more concrete, I want to walk through a specific example. Here I'll talk about an eval-driven LinkedIn Ghostwriter. So this is a project I've been working on for the past couple of weeks, and I actually talked about this in my previous video on error analysis, but just a quick overview of how this system works. Basically, I want to give the LLM raw notes of LinkedIn post ideas, and then I want it to output LinkedIn posts in my unique style and voice. In the previous video, we saw how I was improving this system using the manual feedback loop. So basically, I would generate outputs from the LLM, I would manually review the outputs, evaluate them, and then return to the prompt, refine it, and then continue in this feedback loop. But here, instead of doing manual evaluations, I'm going to walk through how I automated this evaluation process to improve this system even more. The workflow I followed consists of 6 key steps. The first step builds on top of the work I discussed in the previous video, where I used error analysis to identify common failure modes of this LinkedIn Ghostwriter. The second step is to create evals for each of the failure modes. So these could be code-based or LLM-based. The third step is to curate a development and test set of user inputs. So these are realistic inputs that we're going to pass into this LinkedIn Ghostwriter. Then the fourth step is to generate posts from the user inputs in the dev set using the prompt of the LinkedIn Ghostwriter. And then we will apply the evals we created in step 2 to the posts that we just generated. And then we will review the results and refine the prompt. In other words, we can look at all the outputs that failed our evaluations, and then we can use those failures to inform improvements to our prompt. Then we'll go back to step 4, generate more posts, apply evals to these posts, and then again review the results and refine the prompt, and then just continue in this feedback loop. One thing I kind of glossed over in this 6-step workflow is in step number 2, creating any kind of LLM-based eval. Since this is also an LLM system, we're going to have to run through a similar workflow, but instead of evaluating the quality of a post, we're going to be evaluating the quality of our LLM judge. I'll walk through this in a little bit. The first step is to identify the failure modes. And so I talked about this in the previous video, but this consisted of tediously reviewing responses from the LLM, leaving open-ended notes on these responses, and then based on these open-ended notes, categorizing failures into common categories. Here, the two main failure modes I'm going to focus on are one, excessive EM dashes, which are these long hyphen looking things. And the second is bad voice. So basically the post doesn't sound like it was written by me. This first one is actually kind of a meme these days. A lot of people have been noticing that ChatGPT loves using EM dashes, but this is something I was seeing over and over again in these LLM responses here. But this is going to be easy to have an evaluation for. We can just have a code-based check to see if the LLM's output has more than one EM dash. But this second failure mode isn't something we can use a code-based eval for. And that's because I don't know how to write code-based evaluations to see if a piece of text sounds like it was written by me. So for this second one, we're going to use an LLM judge. Since the EM dashes eval is pretty straightforward to implement, I won't talk about that here, but all the code is available on GitHub, so you can check out all the evals, all the prompts, all the experiments, and various posts that were generated from all the different iterations of this. It's all completely free on GitHub. But here I'll just focus on the creation of the LLM voice judge. Again, here is the 6-step process I flashed earlier on how I made the LLM judge. I'm going to walk through this one step at a time. The first step was to create a labeled data set of posts. This is going to consist of manually reviewing posts one at a time and then assigning a label to each of them. So basically saying if the post has a bad voice or doesn't have a bad voice. So in other words, does it sound like me or does it not sound like me? Once we have this labeled data set of posts, we can split it into a train, test, and development set. We'll have a development set. So this is what we're going to use to refine our prompt. We'll have a test set, which is going to be a held out set of data that we never look at, which we can use to objectively evaluate our LLM judge. And then we can have a train set, which includes examples we can incorporate in the LLM judge's prompts. The next step is to create an initial evaluation prompt. This is going to be some basic prompt engineering, and we can incorporate these training examples in this LLM judge prompt. Next, we can pass the dev set through the LLM judge. So we'll take the posts from the development set, we will pass it to the LLM with our LLM judge prompt, and the output of this is going to be a label for each of the posts. This is going to be our judge's prediction of whether the post sounded like me or didn't sound like me. So now that we have the judge's label, we can compare these to the ground truth. And so for each of our posts in the dev set, we have a ground truth label of whether it sounded like me or didn't sound like me. And then we have what the LLM judge thought sounded like me and didn't sound like me. And so we can just compare the LLM judge's predictions to the ground truth. To do this, we can calculate various metrics like accuracy, precision and recall, F1 score. We can look at confusion matrices and things like that. So I'll show how I did this on the next slide. And then finally, we can review the errors and refine the prompt. We can look at the posts where the judge's prediction didn't match the ground truth. And then we can update the LLM judge prompt based on these errors. So one thing I did a lot was what people might call meta prompting, where I basically gave the LLM judge one of these posts that it got wrong, told it that it got the label wrong, and then asked it to suggest improvements to the prompt to avoid that mistake in the future. This was the main strategy I used to refine the prompt. It wasn't very often that I was coming up with improvements. It was me asking the LLM to come up with improvements and then incorporating them into the prompt. Two things I used to help me with this prompt refining process. The first is I created this custom Streamlit app that allowed me to quickly review various prompt versions for the LLM judge, which I'll show in a second. But it allowed me to select different data inputs, compare various prompt versions, select the sample size, look at confusion matrices, look at various performance metrics, and so on. And then the second thing I did was was go to OpenAI's Playground, where I could paste the LLM Judge system prompt, give it a post to evaluate, and then here is where I could give it feedback on its labels. So let's say I'll give it a post. It says it does sound like me, but the ground truth was that it didn't sound like me. And then I go through this conversation of giving it the correct label, asking it if it understands why the label it gave was wrong, and then asking the model to suggest improvements to the system prompt. But just to show you what this LLM Judge Streamlit app looks like, so on the left we have various things, so we can select what input data we want to use, we can pick which column of the data we want to analyze, we can pick the column with the ground truth, we can choose various versions of the LLM Judge prompt that we want to evaluate, we can change the evaluation sample size, we can change the LLM Judge model, and then it's going to run the evaluation. It's going to have these summary metrics. We can see version 7 of the prompt was significantly better than version 6. So the way I would do this was iteratively refine a new version of the prompt until I beat the old version by a significant margin, at which case I would save the newer version and then make a copy of it and then keep refining. Once I hit this level of accuracy, I was pretty satisfied. And it's important to not just look at accuracy, because this is going to be imbalanced data set. So it's important to look at something like a confusion matrix and understanding the false positive rate and the false negative rate. Another cool thing here is that I'll have a full breakdown of all the posts here. And then once I kind of pinpoint a mistake, so let me scroll down and I see 29 was wrong. So let's go take a look at 29. We'll load this. This is post number 29. LLMs get all the hype, but image AI just made a leap. a new state-of-the-art model from X-Stable Diffusion devs. Here's what happened when I fine-tuned it on my face. While everyone's focused on large language models, image generation, okay, whatever. This is the post that the LLM spit out. This is version 6 of the prompt. So you notice that I have the prediction, but I also have reasoning steps from the model. So version 6 of the prompt thought this post sounded like me. Version 7 of the prompt thought it sounded like me. The way I would iterate on this prompt is I would go to the Playground, have the system prompt. So I think this is version 7 of the prompt. I would take this LinkedIn post and then I will pass it into the Playground here. Now it's going to write out all the reasoning steps. You can notice that this prompt is quite long. You can read the whole thing on the GitHub, but I found that giving it the step-by-step instructions and basically forcing the model to generate more tokens led to better performance. Here it said the label is false. The post sounds like Shah. I would say something like, this is actually an example of a bad voice post. And let's see. Sometimes I gave a justification, sometimes I didn't. You know, maybe this, I wouldn't say image AI made a leap. So maybe this is the alarm that's going off in my head. And I'll say like Shah would never say, but image AI just made a leap. And then I would ask it to reflect, like, do you see that? Basically prompt the model to just reflect. I don't want it to go through the reasoning steps again. So I'm going to delete this. And that's a good thing about the Playground. You can do this stuff. And now I can change the prompt I put here and say, do you understand why? And then we'll see if that is any better. So it said, yes, I understand why this post is not in Shah's voice. Let me break down the reasoning in detail, referencing the guidelines and your feedback. And then I would ask it something like, how could the instructions be improved to avoid this mistake in the future? Then I would say something like, for each of your suggestions, please tell me where in the instructions they go, and for the actual changes, provide them in a text box. The reason I want it in a text box is that it's hard to copy paste Markdown, but when it returns in a text box, you can just easily copy and paste it over. And so I would basically just go through, read each of these, and then paste it into a new version of the prompt. Let's say I'm trying to beat version 7 of this prompt. I would make version 8, and then I would try to incorporate these changes, and then just keep doing this until I got a significant lift in performance. performance. And I feel like it actually took me longer to make the LLM judge prompt than it did to make the original LinkedIn Ghostwriter prompt. All that to say is don't expect the LLM judge to just be like a quick thing you implement. This is something that took me maybe a day and a half. It's important that you get the judge right, because if your judge isn't aligned to your preferences and your goals for your system, then everything beyond this step is just going to be garbage. Now that we have the LLM judge and our code-based eval as well, we can go to step 3, which is to curate user inputs. Here, I have a set of 49 realistic LinkedIn post ideas, which I just wrote out manually and also grabbed from the past. I have a Notion database full of past LinkedIn post ideas, and I was able to grab some of them from there. The way I split this up is I took the first 30 inputs as the development set. I took the next 10 for the test set, and then I took the final 9 to be part of the training set. And I don't even think I used the full training set for this. Now that we have the realistic inputs, we can use them to generate posts. So what I did is, because this can take a long time to go through this whole pipeline, generate 10 post ideas with this really long prompt and all these writing steps, then to evaluate the posts with the LLM judge. Like if I did all 30 every single time, it would take a lot of time and would cost a lot of money. I was spending about like $5 to $10 a day on running this system and running all these experiments. So I guess the good news is I now have tier 3 usage of OpenAI's API. But for this step, I would take these ideas, I would pass them to the LLM. Now we have a prompt for the LLM to generate LinkedIn posts in my style, and this will spit out 10 different LinkedIn posts. And now that we have these posts, we can go to step 5 and apply the evals to them. Again, I have 2 evals, one to evaluate the voice and the other to evaluate the number of EM dashes. This eval will fail if the post has more than one EM dash. And then we can summarize these post level evaluations into various aggregated metrics. For each eval, we can have a pass rate. So let's see, this one passes 4 out of 10 times. So this would be a pass rate of 40%. This one would also be a pass rate of 40%. And then we can average those two together. So this would give an average pass rate of 40%. And then I had these other 2 eval metrics of the percent of times that all the tests pass, and then the percent of times all the tests failed. These all just give slightly different perspectives and angles at the performance of the system. But either way, once we have computed these evaluations and have this global metric for its performance, we can review the results and refine the prompt in much the same way we did for the LLM judge. The way I did it is I looked specifically at the posts that failed both sets of evaluations, and then I went back and refined the LinkedIn Ghostwriter's prompt to avoid these mistakes in the future. And so again, I had a custom Streamlit app to help me look at the data and understand why a post was bad and navigate it. So I'll show that in a second. And then I would go to OpenAI's Playground to do meta prompting and basically ask the model to suggest improvements to the system prompt. Here's the Streamlit app for reviewing the experiment results. I ran a bunch of experiments, but the key thing here is we have the prompt version, the data set where the inputs are coming from, and then the number of posts evaluated. So this experiment evaluated 30 different posts. I have some high-level metadata about the experiment here. And then I have various filters. And so I can just have all, or I can filter by pass-fail. So I would look at cases where both would fail. Okay, so this one was actually pretty good. So let's go to an older prompt. I would look at the posts where it failed both of the evaluations, and then I could just go through and review them manually. This one failed both ones. So most top AI engineers aren't more intelligent than you. They just build more. The real difference isn't raw intelligence. It's putting ideas into practice. Top engineers start with small, messy prototypes, ship, whatever. We can see why this failed the EM dashes because it has 2 EM dashes, but the voice is a bit trickier. So that's why I print out the reasoning steps here, and I'll just like read through this and try to understand why. And then to refine the prompt, I would go to another playground. So now the system prompt I have here is the one for generating LinkedIn posts. This isn't for the LLM judge. This is for the LinkedIn Ghostwriter. And then basically I would simulate this conversation. So I would insert the user input here, and then I would grab the reasoning steps. So to like simulate this conversation. And then the reasoning steps in the final post are returned separately. So then I'll go back and copy the final post. So I have this, I have this. Then I would say something like a LinkedIn post evaluator gave the following grade to this post. Do you understand why? And then I would add some triple backticks and I would add a grade of failed. Then I would go back over here and copy the reasoning. So now I'm giving the LLM the feedback from the LLM judge. And then I would say something like, how could the instructions be improved to avoid this mistake in the future? And then I'll do a similar kind of thing that I did before, asking it to return its responses in text boxes and then just manually copy pasting it into the instructions. The result of all this is shown here. So I went through many different versions of the prompt, but I only kept new versions if they did better. But eventually I got to a version of the prompt that was a significant improvement from the original. So the pass rate went from 0.33 to 0.9. The percent all passed went from 0.13 to 0.8. The percent all failed went from 0.47 to 0%. So that's a big lift there. The EM dash pass rate, this was a lot of work to fix. For whatever reason, the LinkedIn Ghostwriter just refused to have one or fewer EM dashes in the post, but I eventually got something in prompt version number 5 that got a significant improvement. And then the voice pass rate went up to 0.9. And so these are the dev set results. I also had the test set. Unfortunately, there were only 10 posts in this one. I guess I could just generate more with the same inputs and that might be fine, but we're basically seeing the same statistics as the dev set and the test set. So I don't think it's overfitting to the development set. But the key point here is that now that we've automated evals, we now have clear and objective metrics to tell us if our prompt is getting better or not. Otherwise, if we're just doing manual evals, it's easy to get lost and not really know if your improvements are actually improvements in making the system better. But by automating evals, you can run these objective experiments and get hard metrics that guide your development. And so this is why it's so powerful to build out evals and try to automate them. Here's a quick little example of this system. This is a LinkedIn post idea I have for a future post. I haven't written this one yet. So it's if you can't explain something simply, you don't understand it. This is what my Ghostwriter came up with. If you can't explain something simply, you don't understand it. I've lost count of the number of times I thought I understood an AI concept only to get tripped up when trying to explain it to a friend. This is a great test if you find yourself stuck using jargon or your explanation circles around without landing. There's probably a gap to fill. Practical habit. Try explaining a new idea as if you're teaching someone with no background. Write it down in 2 to 3 sentences. If you can't get through it without stumbling, it's a signal to revisit the basics. This method helped me learn faster and spot weak points earlier. How do you check if you truly understand a topic? So I would say this is actually pretty good. I agree with this post. Maybe there are a few things that I wouldn't say, like circles around without landing isn't something I would typically say. But overall, the essence of the post is something I agree with, and maybe it would just take a few tweaks to be something that I would actually post. Now let's compare this to basically giving this prompt to ChatGPT and asking it to come up with an output. This sounds a lot like ChatGPT. So if you can't explain something simply, you probably don't understand it deeply. Like the hook is good. This used to frustrate me. I'd be halfway through explaining something, an algorithm, an idea, a process, and realize I was rambling. That doesn't really resonate with me. It also likes using these threes. It likes to go like 1, 2, 3. Here's another example. Backtrack, try metaphor, still clunky. Zoom in, ask better questions, rewrite it until it clicks. While I don't really do that in my writing, I don't talk like that. I'm really happy with the final results here. Before doing this eval-driven approach to prompt engineering, I would have thought in order to get posts like this, I would have to fine-tune an LLM on my past writing. But I didn't do any fine-tuning here. This was just through prompt engineering, doing error analysis, creating automated evals, evals and then just iterating on the prompt, I was able to get something that is pretty good a lot of the time. And now if I want to take this to the next level, I already have so much infrastructure set up that fine-tuning will be relatively straightforward, but it's just amazing how far you can go with prompt engineering. And so that's one thing that was very eye-opening about this project. All the code and prompts and everything for this project is freely available at this GitHub here. Shout out to Hamal Hussein and Shreya Shankar, whose AI course on evals was a major eye-opener for me and is what prompted creating this project. You can check out Hamal's content. He has a bunch of awesome content on his YouTube channel that I highly recommend on evals, so I'll link that in the description as well. But if you have any questions on evals or this project, let me know in the comments section below. And as always, thank you so much for your time, and thanks for watching.